Hello everybody. Today I'd like to talk to you about page 8 of our chapter 8 study guide. It is about the light-independent reactions of photosynthesis. This is where we take the NADPH and the ATP produced in the light-dependent reactions of photosynthesis, and we use them to produce sugar in the Calvin cycle. This occurs in the stroma of the chloroplast, and I guess the way I'm going to show it is I'm going to show bringing in all 6 carbon dioxide molecules at once rather than one at a time. That makes more sense to me. So first we'll identify that these 6 black dots here represent 6 carbon dioxide molecules from the atmosphere. They came in through the stomata and diffused into the cell and then diffused into the chloroplast stroma. We're going to need 6 carbon dioxide molecules because sugar in the end is a 6-carbon molecule. So one way to look at it is this. We need to combine these 6 carbon dioxide molecules with these 6 5-carbon molecules here, like this, and then when they come together, the carbon atoms will be combined into that molecule. Well, let's just try to explain it this way. Right here I've got 6 molecules of ribulose bisphosphate. Ribulose bisphosphate is usually abbreviated RUBP. The reason I have 6 molecules is because each one of these 5-carbon RUBPs are going to attach to these 6 carbon dioxide molecules. So let's just keep track of the carbon here. We have 6 times 5 carbon, and of course that equals 30 carbon. And each of these ribulose bisphosphate molecules is going to combine with each of these 6 carbon atoms to form a unstable 6-carbon molecule, each of which breaks in half to form 6 3-carbon molecules called PGA. This can't occur without the help of an enzyme, and in this case we're dealing with an enzyme called RUBP carboxylase. We know it's an enzyme because it ends in the ACE. And so RUBP carboxylase comes in here, catalyzes the reaction in which these 6 carbons get attached to these 6 molecules. Once that happens, as with the case with enzymes, RUBP carboxylase is the same at the end as it was at the beginning and released to do its work again. So this process in which carbon dioxide from the air, gaseous carbon dioxide, is incorporated into an organic molecule here with the help of RUBP carboxylase, that's called carbon fixation. You could describe it as capturing gaseous carbon from carbon dioxide and incorporating it into an organic molecule. Now if we were to follow this, we would see that each one of these 5 carbon molecules receives one of these carbon atoms. You'd have 6 carbon molecules now, and those 6 carbon molecules would each break in half, forming 12 3 carbon molecules. Each of these 12 3 carbon molecules is called PGA. That's an abbreviation. So how many total carbons do we have now? Well, we got 12 times 3, and that equals 36 carbon. And that makes sense because we had 30 over here, and we added 6. Now here's where we bring in the NADPH and the ATP from the light-dependent reactions. If we take 12 ATP and we use the energy from them, and we take 12 NADPHs and we use the electrons from them, there's a chemical pathway that converts these 12 PGA molecules into something called PGAL. Still 36 total carbons. I've now eliminated the black circles because these 6 carbon are just incorporated into these organic molecules now. It doesn't matter where they are. Well, then you can set aside some of these PGALs. Take these 12 PGALs, set aside 2 of them to be used to make the sugar down here. That leaves us with 10 PGALs. Well, we're back to 30 carbons now because 10 times 3 is 30. So now if we take these 10 PGALs and we use 6 ATPs from the light-dependent reactions to help carry out a series of chemical reactions in which these 12 PGALs, which equal 30 carbon, rearrange themselves and produce the original 6 RUBPs again. We had 10 times 30 is 30 carbon. We still have the 30 carbon, they just have undergone a chemical change, and now they're back to the starting molecule of RUBP. These 6 RUBP molecules will pick up more carbon dioxide from the air, fix the carbon, and make more sugar, and so on, and so on, and so on. So I suppose you could consider that these 6 carbon that we pulled out of the air have become these 6 carbon in this precursor to a sugar molecule down here. I don't know that they're the same 6 molecules, but we need these to have enough carbon atoms to make the sugar. Now that's the Kelvin cycle. It's a little bit confusing. You'll see it different ways in different places related to the numbers used. A lot of times they'll say it has to turn 6 times to make a sugar because the sugar is a 6 carbon molecule. You got to take 6 carbons out of the air. It's hard for me to wrap my head around that, so I just think of it turning once, bringing in all 6 at once, as I've shown here. Whether or not that's accurate, it makes more sense to me.